Assalamualaikum and hello everyone. Today we are going to take a look at chapter 3, which this chapter consists of 4 different subtopics. The first one is differentiation of exponential functions. The second one is differentiation of logarithmic functions, followed by the differentiation of trigonometric functions. And then we're going to take a look how to differentiate functions involving all those 3 functions that you have seen in the first 3 subtopics. Okay, so in this video, I'm going to focus on the first subtopic only. Before we start, I'm going to take a look at the learning objective. So, the learning objective for this subtopic is for you to be able to differentiate the exponential function in the form of f of x is equal to e power of x and fx is equal to e to the power of yx. Next, we are going to take a look on how to differentiate exponential functions. So exponential functions are those that you have seen in the learning objective where we have fx is equal to e power of x or f of x is equal to e power of yx. So these two functions are what we call exponential function. And for the first one where we have fx is equal to e to the power of x, this is what we call as simple exponential function. So the theorem says if we differentiate the simple exponential function, the derivative will be the same as the original function. So dy dx is equal to e to the power of x. And then if you have e to the power of kx, where k is also a constant as we see previously for index function, the derivative will be k times e power of kx. And lastly, if we differentiate e to the power of fx, where fx is another function, then we will have e to the power of fx multiplied by f prime x. And if you recall previously for simple index function, we have that tips where we can just take c times d times l. It's still the same here. First, we just need to copy whatever we need to differentiate, which is the exponential function. And then we just need to multiply that with the derivative of our power. And then if you recall, we have another one which is ln of our base. Okay, so taking the ln of our base, in this case it was not shown because the value is actually 1, because here our base is e. So ln e, if you calculate this using your calculator or you just remember this, the value is 1, so you don't need to write that, but the tips is still the same and the method is still the same. Now we are going to take a look at the proof for those 3 theorems for differentiating exponential function. In this case, I'm going to focus on the method using the chain rule. Okay, first we are going to start by having y is equal to e to the power of fx, and then what I need to do here is I need to let u is equal to fx. Once I let fx is equal to u, I can differentiate that with respect to x, giving me f prime x. And then I can also rewrite my original function y into y is equal to e to the power of u. And again, I can differentiate this with respect to u, giving me dy by du is equal to e power of u. And then, because we are going to use chain rule, please recall our formula for chain rule is dy by dx, because that is what we want to find, is actually equals to dy by du multiplied by du by dx. And those two derivatives are what we got here. So we just need to put in, giving me e power of u times f prime x, resubstituting my my u is equal to fx. That will give me f prime x times e power of fx, and that concludes our proof. Now we are going to work on the next example where we need to find f prime x. For the first question, we have fx is equal to 4 e power of x. This is an example of just a simple exponential function. So for this function, we are going to differentiate directly. First step, we just copy everything, and then we are going to multiply by the derivative of the power. So we have there 4e power of x multiplied by differentiate x with respect to x, giving us 1, and the final answer will be f prime x is equal to 4e power of x. For the next question, we have fx is equal to e power of 3x, where here we have constant k is equal to 3, and we are going to differentiate that again using the same method, copy everything and then differentiate our power. We are going to have f prime x is equal to e power of 3x multiplied by 3, rearranging that for our final answer, giving us f prime x is equal to 3e power of 3x. For the third example, we have fx is equal to e power of x squared. So here you need to take note, this is in the form of e to the power of yx, and we just need to differentiate our power there. So that gives us f prime x is equal to e power of x squared times 2x, and we can rearrange that to give us 2x times e power of x squared. As for the last one, here our power consists of the square root function, so we just need to again differentiate the power properly later on. So f prime x is equal to, we just copy everything, which is e power of square root of x multiplied by the derivative of square root x. So derivative of square root of x is equal to 1 over 2 third x, and our final answer can be rewritten as f prime x is equal to e power of third x over 2 third x. Now let's take a look at example 4. For example 4, I'm going to focus on different types of question requiring us to use different techniques of differentiation. So for the first one, we are going to go from the easiest to the hardest. So this one you can just immediately differentiate using the tips that we have learned previously, where we just copy everything and then we are going to differentiate our power, and that gives us dy dx is equal to e to the power of negative 3x squared plus 4x multiplied by 4 minus 6x. And you can just rearrange putting 4 minus 6x in front, and that after we know how to differentiate simple index function and exponential function, we can now take a look on how to find the higher order derivative. In this case, we are going to focus more on the second derivative. So how do we find the second derivative? This means that you have to differentiate twice. Two times. Okay, so we are going to differentiate with respect to x two times so that we can find our second derivative. So for first example, we have y is equal to e power of x cubed. Here we need to find dy dx first, and we just need to copy, multiply by differentiate power, and we get e power of x cubed times 3x squared. Rearranging that, that will give me 3x squared times e power of x cubed. And before I find my second derivative, I need to see here properly that we have the product of two functions here, where my first function is 3x squared and the second function is e power of x cubed. So if you need to differentiate this, we need to use product rule. So please recall the formula for product rule is VU prime plus UV prime. We need to first determine our U and V. So my U will be 3x squared and my V will be e power of x cubed. Differentiating U, giving me U prime is equal to 6x, and my V prime will be 3x squared e power of x cubed. And since my formula here requires me to add those two, I can just rewrite that here, and that gives me d2y by dx2 is equal to e power of x cubed times 6x plus 3x squared times 3x squared times e power of x cubed. And now what I need to do here is I just need to factorize the like terms. So whatever in front and behind that is the same, we can just take that out, and our final answer will be 3x times 2 plus 3x cubed times e power of x cubed. Now, I'm going to ask you to do some exercise, because these exercises are meant to check whether you do understand what we learned in this subtopic. So you have the question there. in the black color font, and then on your right hand side you are given the final answer for you to check once you have. Okay, so now for the second question, we have y is equal to x e power of 4x. And again, if you take a look properly here, we have the product of two different functions. So if you want to differentiate the product of two different functions, you are going to need to use the product rule. So if you use product rule, you will need to label this as u and v. So we are going to have my u here will be x and my v will be e power of 4x. Differentiating those two, giving me u prime is 1 and v prime is 4e to the power of 4x. And again, because the formula for product rule is vu prime plus uv prime, I just need to write add that. Okay, putting into the formula, I'm going to have dy dx is equal to e power of 4x times 1 plus x times 4e power of 4x. And again, we are going to factorize the like terms, giving me the final answer is e power of 4x times 1 plus 4x. As for the third example, now we have fx is equal to 3x plus 2 over e power of x, and again because this one I'm going to divide 3x plus 2 divided by e power of x, we just need to label u and v, but now we are going to use the quotient rule. So for the quotient rule, please remember the formula is vu prime minus uv prime. Everything is divided by v squared. So my u will be on top, my numerator 3x plus 2, differentiating that giving me 3, and then my v will be my denominator, which is e power of x. So my v prime will still be e power of x, and here I'm going to write minus. So now putting into the formula, I'm going to get e power of x times 3 minus 3x plus 2 times e power of x over e power of x, everything squared. So now we just need to cancel like terms on the numerator and denominator. That gives me the simplified answer where f prime x is equal to 1 minus 3x over e power of x. And again, those examples are followed by exercise where I need you to try. You are given the question, 4 different questions where you are going to need to use product rule and quotient rule, and then you can check your answer with the provided final answer. So before we end the lesson, I'm going to ask you to answer some questions as a skill test, because the purpose of this skill test is to check whether you do understand what we learned today, and if you cannot do this question or if you cannot understand the concept, please refer to your lecturer. So we have 4 different questions, and again I've provided the final answer, but this time at the bottom of the slide. So please refer to your lecturer if you cannot solve any of the problem. Okay? And we now have reached the end of the first subtopic. So thank you.